Hey all, lesson 6.2, the slope of a line. Take a moment to read over your learning targets. What is a slope? Let's talk a little bit about it. Slope, we discussed rate of change last time we were together in class. A slope is a constant rate of change for a given line. In our toolkit, we can actually see a calculation used to calculate slope. Slope is given the variable m in algebra. It's equal to your change in y over your change in x, as we can see here, y2 minus y1, x2 minus x1. The subscript here of the 2 and the 1 just would mean that y1 and x1 come from the first point, y2 and x2 come from the second point. Some people call this the rise over the run. So we consider the change in y over the change in x. The x is the denominator because x is most often used to keep track of time, the independent variable. So that's why we do the change of y over the change of x. So in this example, we can find the slope in the graph below because it is a line and there is a constant rate of change. In this example on the right here, we cannot find the slope in the graph because it is not a line. There's not a constant rate of change. We can see that it's kind of a quick rate of change here. We would call that maybe a steeper line compared with the rate of change here, and we can actually see the lines are going down, and then we can see an up, and then we can see a flat. So we can see that there is no constant rate of change, so we wouldn't say that there's a slope to this graph. We could isolate different parts and find different slopes. We find the slope of the line in the graph. Right now we're going to find the slope of the line from the graph of the line in the previous set of examples. So we're going to go ahead and take a look and see what this looks like. Taking a look here, the change in y over the change in x. So in order to use our formula here, y2 over y2 minus y1, x2 over minus x1, we are going to have to pick an initial point and the end point. It doesn't really matter which one you pick as which, as long as you're kind of consistent and stick with your pick. So I'm just going to go ahead and say green is my starting point and red is my end point. It kind of seems maybe a little bit backwards, but again, it doesn't matter as long as we're consistent. So this makes my y2 a value of 10 and my y1 a value of 7. My x2 takes on a value then of 15 and my x1 takes on a value of negative 3. So it doesn't really matter as long as the y2, x2 come from the same point and the y1, x1 come from the same point. We'll go ahead and calculate here. We come up with a change in y of 3 and a change in x of 18. And now we'll simplify. The slope here is 1/6, 1 over 6. So in this, we can see the change in y over the change in x. That would mean that x goes up by 1. When the change in x goes up by 6. I'm saying up because they are both positive values. So let's calculate the slope of the line through the points 312 and 18.3. We're going to be calculating the change in y over the change in x. We'll need to identify the initial and the end point. Again, it doesn't really matter. One is the starting point, one is the end point. I chose green for starting point, the initial point, and red for the end point. So now we'll change in our values. It looks like we've got a 3 minus a 12, so this is my y2, my y1, and an 18 minus a 3, my x2, and my x1. So we're being consistent here. We're going to calculate negative 9 over 15. Simplify. This is negative 3 over 5. As we take a look, the negative can apply to the numerator or the denominator. So what we can say is that y goes down by 3 when x goes up by 5. We can actually see that on the graph here. Y goes down by 3 if x goes up by 5. Down by 3 if x goes up by 5. Down by 3 if x goes up by 5. So we can see that actually being pretty consistent here. Or we can say that y goes up by 3 when x goes down by 5. So we could also say that y is going up by 3 if x goes down by 5. So in the case of the negative slope, one value is increasing while the other value is decreasing. Finally, we're going to talk about how to calculate slope from the graph of line. It's similar to what we saw in the final explanation on the last example. where we said that the slope was negative 3/5 because y either went down by 3 and x went up by 5, or we can see y going up by 3 as x goes down by 5. So we have to determine two identifiable points on the graph, for example 312 and 89, or 18.3, and then we can also see a point here at 11.6. And then we need to identify the change in y and the change in x. And then we would go ahead and simplify the fraction. So as we work through, we're going to find the slope of the line M in the graph at the right. The line M is this kind of downward line here. So we're going to follow the steps. Two identifiable points. We've got the point negative 2, 4 and the point 2, 0 as identifiable points. We can follow this to go from 2, 0 to negative 2, 4. We went up 4. So that's our change in y is a positive 4. And we had to go back 4. So that's our change in x is a negative 4. So we put our change in y over our change in x. And we can see that that simplifies our slope here is a negative 1. So let's talk about how we can calculate slope from the equation of a line. Calculating slope from the equation of a line is to take a look at using the equation to identify 2 points. Once we've used the equation to identify 2 points, we would use the points to find the change in y and the change in x and simplify just as we did. So as an example, we are going to find the slope of the line x plus 3y equals 9. So find any 2 points. 2 points that are generally easy to find occur when we take a look at x being 0 or y being 0. If x is 0, that means we've got 0 plus 3y equals 9, so y equals 3. And if y is 0, we've got x plus 0 equals 9, so x is 9. We're going to choose an initial point and an end point, substitute our x's and our y's. So here I'm doing change in y as 0 minus 3, change in x as 9 minus 0. If we calculate here, we have negative 3 over 9. If we simplify, that's negative 1/3. That's the end of this one. Go ahead and take a look at 6.3. We're going to talk about some properties of slope.